Greetings. This is to be a lecture on the demarcation of science and the rationality of scientific theory preference. It's taking, I very briefly go over Karl Popper's idea of what constitutes the rational grounds for theory preference in science and how science is supposed to progress. But what we'll be looking at principally in this presentation is the critique of that view offered by Thomas Kuhn. Now, this is all rather abstract, and hopefully you'll be clear once I get started with the presentation. So let me do that. I'll share my screen. Here we are. So the principal focus of this presentation is a work by Thomas Kuhn called The Structure of Scientific Revolutions. But I will reference Popper in a bit because he's reacting to Karl Popper, an earlier philosopher of science. This isn't working. And why is it not working? There we are. So Karl Popper claimed that science moves forward by means of falsification. Popper set some very high standards for scientific rigor. He wanted scientists to constantly set out to disprove their work. Any scientific theory, to Popper, is always in the state of being not yet disproved. Now, what does he mean by that? Well, Popper is pointing out that we cannot really verify a theory as true, because verification would have to go something like this. If my theory T is true, then I will have observational experimental result O. I have observational experimental result O, therefore my theory T is true. But notice, back from when we were looking briefly at logic, that's a fallacy. That's the fallacy of affirming the consequent, and nothing really follows from the conjunction of premise 1 and premise 2. Again, this is the fallacy of affirming the consequent. Nothing strictly follows from the premise set. If T, then O, O. Right? Now, testing for Popper actually has to take the form of trying to disprove or falsify the theory, not to verify it. Because notice, to falsify a theory, we have this. If my theory T is true, then I'll have experimental result O. I don't have experimental result O, therefore my theory is not true. Well, that's a valid inference. That's modus tollens. And again, there's nothing wrong with that. That's deductively valid. But this means that theories can only be falsified. They cannot actually be verified. So the way Popper thinks science proceeds is that we have a purported theory. Scientists test it, and by test it, he means they construct experiments to see whether or not the predicted results occur or not. If the predicted results do occur, that doesn't actually confirm the theory. It just doesn't falsify the theory. On the other hand, if the projected results don't occur, now we have a reason to think that the theory is false and we should abandon it or modify it or move on to something else. So this is how Popper thinks science progresses. It progresses by deduction. Notice for Popper, it does not progress by induction. There is something to be said for this approach of looking for data to contradict your beliefs rather than more data that supports them. Instead, Popper is using the potential conflict between a theory and its predictions and actual data about the real world to drive science forward. Popper argues that science is accountable to rigorous objective standards, in particular falsification, which he regards as the core of science. Again, that deductive modus tollens process. This is how science progresses, according to Popper. But further, this is what demarcates genuine science from pseudoscience. So for instance, Popper was famously critical of Marxism, and he's critical of Marxism because he claimed that Marxism began as a genuine scientific theory which made predictions about what would occur in the future. But those predictions turned out to be false. Now, rather than go, oh, I guess we've disproven Marxism as a bold scientific claim about the progress of history, Marxists instead remodified the theory to try to make it consistent with the actual observed results. But this makes it into a non-falsifiable set of claims. And if a theory is not falsifiable, then it can't be science. So for Popper, what demarcates genuine science from pseudoscience is that genuine science consists of theories which are falsifiable, whereas pseudoscience does not. But later philosophers were critical of Popper's view. This, they claim, was an idealized science at best, and is not how actual science is practiced. For instance, when he looked, Thomas Kuhn couldn't find much evidence of this falsification actually happening in practice, in the actual history of philosophy. So when Thomas Kuhn is looking at the history of science, rather, when Thomas Kuhn is looking at the history of science, he's saying, well, this claim that Popper is making is not really describing what goes on in science. It's idealized, or it's a rational reconstruction, but it's not what's actually going on by scientists when they practice science. Thomas Kuhn developed a theory of science and scientific progress that directly challenges that of Karl Popper. He argues that most of the time science, what he called normal science, operates within a set of given assumptions or paradigms that are taken as given and not subject to testing. If true, this would greatly restrict the extent to which Popperian disproof does or could actually happen. In fact, the paradigm, as conceived by Kuhn, becomes a sort of fundamentalist orthodoxy about how the world is. Normal science is merely the process of elaborating the paradigm or the central theory in greater detail. A whole generation of scientists grow up with a set of common assumptions, and, according to Kuhn, as a matter of historical fact, they exhibit a strong resistance to any data that might call into question the central paradigm. Originally printed in an article in the International Encyclopedia of Unified Science, we see the early work of Kuhn, The Structure of Scientific Revolution. Here, Kuhn argues that science does not progress via a linear accumulation of new knowledge, but undergoes periodic revolutions, which he calls paradigm shifts. He reviews past major scientific advances and attempts to show how the steady accretion of scientific progress via normal falsification view of scientific progress was wrong, or at least incomplete. Science advanced and advances the most by revolutionary lurches forward, each revolution introducing seismic reconceptions of the way the world is, so large that they must be called paradigm shifts. Kuhn is responsible for popularizing terms like paradigm, paradigm shift, and paradigm change. So a paradigm refers to a typical example or pattern of something or model, right? Say, oh, there's a new paradigm for public art in this country, right? A model for understanding it or engaging with it, etc. It could also refer to a worldview underlying the theories and methodology of a particular scientific subject. This is how Kuhn is understanding the term paradigm. It also has use in linguistics as a set of linguistic items that form mutually exclusive choices in particular syntactic roles. We don't really need to worry about that notion. We're concentrating largely on the middle one. Thomas Kuhn defines a paradigm as universally recognized scientific achievements that, for a time, provide model problems and solutions for a community of researchers. In short, a paradigm is a comprehensive model of understanding that provides members of a field of science a perspective on what the problems of the field are, how to go about solving them, and what a proper solution would look like. So notice the work that a paradigm does according to Kuhn. It suggests that here's the proper way of framing the problem. Here's what would constitute evidence for or against this particular solution to the problem. And here's what we're looking for as a solution. So you really need the paradigm to conduct any kind of research. Before you can go out and start collecting relevant data, you first have to know what the problem is you're trying to solve and what would constitute relative data. The paradigm provides you with both. It provides you with an articulation of the problem, and it also suggests what the relevant data are. Paradigms, quoting from Kuhn rather, paradigms gain their status because they are more successful than their competitors in solving a few problems that the group of practitioners have come to recognize as acute. Thus, Kuhn challenges the traditional understanding of how science progresses. He argues that the history of science is punctuated by moments of revolutionary breakthroughs, again, what he calls paradigm shifts. During these times, the entire scientific discipline is transformed. Kuhn outlines 6 distinct stages with respect to scientific progress. Let me editorialize just for a moment. A clear example of what Kuhn has in mind would be the paradigm shift that went into the Copernican revolution when it comes to the motion of celestial bodies. The reigning paradigm for thousands of years was that the Earth is fixed and does not move, and all the celestial bodies move around the Earth, orbit the Earth. That was the reigning paradigm. Now, even when observations came to light that seemed to be somewhat inconsistent, what they did was kept tweaking and tweaking and tweaking the paradigm so that it essentially remained the same. It just got more complicated so that it was consistent with observation. Notice what didn't happen. What didn't happen is that they said, oh, wait a minute, our paradigm predicts that we would see X. We don't see X, therefore our theory must be wrong. That was resisted for thousands of years. That was resisted, right? And it wasn't until the Copernican revolution where the entire paradigm is scrapped and a new paradigm takes over, the heliocentric model, as opposed to the Ptolemaic model. Well, that is typical of how science progresses, according to Kuhn. Not falsification, where a bunch of rational scientists canvass the evidence and realizes now we have observations inconsistent with the claims of the theory, and therefore scrap the theory and move on. No, they don't move on. They hold on to the reigning paradigm for as long as possible, sometimes an entire generation or so. This is what Kuhn suggests. All right, so moving on then. Kuhn outlines 6 distinct stages with respect to scientific progress. The first stage is what he calls pre-science. Here, there is a general lack of any unifying central paradigm. So we don't have a paradigm. That's why it's pre-science. Science can't even start when we're in this area, right? In a given discipline, the stage only occurs once, according to Kuhn. Subsequently, there's always an existing paradigm, given a discipline of science. All new fields begin in pre-science, where they have not begun to focus on the problem area. Where they have begun to focus on the problem area, but they are not yet capable of solving it or making major advances. Why? Well, because they're aware of certain issues they'd like to understand better, but they don't know how to articulate the problem, and they don't know how to gather data, and they don't know what data would be relevant. And so there would be some sort of a indiscriminate collecting of facts. Like, I don't know, imagine I had no idea what the causes of a certain disease are. So I might start collecting, I don't know, the astrological signs of the people who come down with that view, or their music preferences, or their hair color, or their mother's maiden names. Well, none of that would matter. It does. I don't know that in the pre-science. I don't know whether any of that data is relevant or not, because I don't have a reigning paradigm to say, yes, that's a likely possibility. It's likely that eye color is relevant, or hair color is relevant, or it's likely that genetic heritage is relevant. I have to begin with a paradigm in order to know what facts to collect and what facts to ignore. So we're in pre-science initially. Here, there's a general lack of the unifying paradigm, as I mentioned. The field cannot make major progress on its central problems at this point because it does not know and therefore cannot articulate what the major problems are. Likewise, it cannot tell what an answer to the problem would look like. At this period, one starts from ground zero and attempts to build science from scratch. Because there is no paradigm to organize the data, all facts seem equally relevant. Science consists in the simple data collection with no real organizing principle. But then we move from pre-science into normal science. During this phase, science operates within an overarching paradigm, which guides them in their research and the formation of questions, conducting experiments, data gathering, etc. The paradigm provides them with a means to ask the questions and test the answers to those questions. This is a puzzle-solving phase. Guided by the paradigm, normal science is extremely productive. When the paradigm is successful, the profession will have solved problems that its members could scarcely have imagined and would never have undertaken without commitment to the paradigm. So the paradigm does allow for scientific progress. Now, progress consists of data collection and cleaning up the details, etc., but not disproving the paradigm. In fact, it's not clear how one could disprove the paradigm, since the paradigm governs how data is interpreted. In this stage, scientific progress consists in extending our knowledge of the facts as delineated by the paradigm, working on those issues highlighted as important by the paradigm, increasing the match between the observations and the paradigm's predictions, and further development and articulation of the paradigm. So this is what constitutes scientific progress in the stage of normal science. Note what does not constitute progress in the state of normal science: abandoning the paradigm. No, you're simply cleaning it up, you're extending it, you're giving it more detail, etc. Scientists doing normal science do not work to refute or overthrow the paradigm, or even to find out whether it is true, according to Kuhn. They presuppose that the paradigm is true, and they work on that assumption. But if and since the paradigm forms the operating assumptions needed to do science, ipso facto, it cannot be falsified. Why? Well, because all the data you're collecting is being collected and interpreted by the paradigm. So the paradigm is going to interpret the data in a way consistent with itself. This puts Kuhn in direct opposition to Popper and the claim that falsification is the engine of scientific progress. But then we move on to stage three. Stage three, according to Kuhn, is model drift. During this period of normal science, the failure of a result to conform to the paradigm is not seen as refuting the paradigm, but rather is interpreted as a mistake of the researcher. A few anomalies, cases in which the observable facts do not match up with what the paradigm has led us to expect, they can always be explained away. Oh, the experiment was badly performed, or maybe the beakers weren't washed thoroughly, or maybe the machine was on the fritz, or maybe there was a gravitational field from a planet we haven't discovered yet. So you can explain variations in your experimental results that differ from what the paradigm predicts by essentially chalking it up to some mistake in how the research was conducted, or what the researchers did, or the equipment being used, or something like that. However, we move then from that stage to model crisis, stage 4. Kuhn claims that as anomalous results accumulate, the paradigm comes into a crisis stage. As anomalies accumulate, there grows the suspicion that there's something fundamentally wrong. Again, Kuhn argues that in seeming opposition to Karl Popper's notion that science corrects itself and progresses via the falsifiability criterion. So again, there's a sense that something's terribly wrong, but the paradigm is still embraced by the researchers. And what Kuhn is pointing out is the historical locatedness of actual science and research. Notice these individuals, they built their academic careers, their scientific research careers based on the paradigm. So there's an emotional commitment to it. There's a professional commitment to it. There's a reputational commitment to it. There may be funding commitment to it. And so if your funding and your reputation as a researcher all depends on this paradigm that is starting to go awry, you're going to resist it. You're going to resist giving it up, and you're going to defend it as much as you can. This moves into stage 5, model revolution. At this point, a new paradigm is formulated. A new paradigm, if it is to be successful, must subsume the old set of accumulated observations, both the anomalous results and the non-anomalous results, into one coherent framework. Even so, there will be resistance within the scientific community to adopt the new paradigm. There is an inherent conservative impulse in science, according to Kuhn, and the old guard scientists will seek to preserve their previous worldviews. So again, think of the great resistance that the Copernican revolution was met with, right? Not just for church and religious reasons, but it really meant the overturning of hundreds of years of ways of engaging and explaining the celestial bodies. So it wasn't simply, again, a religious motivation. There seems to be, as Kuhn says, this conservative impulse built into science. Eventually, the alternative paradigm was put forward, that the sun is the center and the earth goes around it. And what it's supposed to do, according to the first bullet here, was subsume all the observations which were consistent with the old paradigm, as well as all of the observations that were inconsistent with the old paradigm, and therefore show itself to be superior to what it's trying to replace. Ultimately, we have stage number 6, paradigm shift. At this point, the new paradigm is accepted and the old one is discarded. This was termed revolutionary science. Hume suggests that this may take a generation or so. He literally thinks that a certain generation of scientists needs to die off in order for the new paradigm to get general acceptance within the scientific community. The change from one paradigm to another is not dictated by observational data in any straightforward way, according to Kuhn. For a time, both paradigms will have ways of accommodating the data via rescue hypothesis, right? Think of Ptolemy's epicycles and diffidence to account for the fact that Mars seems to be backing up in the night sky, etc. Proponents of the different paradigms may have different interpretations of the criteria for theory choice, so that a theory A looks simpler and more coherent with existing theory to proponents of theory A, while theory B looks simpler to proponents of theory B. So again, think back how, for a time at least, it was held by proponents of the geocentric model that their theory was more consistent because their theory had the moon going around the earth along with everything else. And they charged their opponents, the heliocentric model, with being less consistent because it says everything goes around the sun except the moon, which in fact does go around the earth. Well, from the geocentric model, their view is more coherent than the heliocentric model. Of course, the heliocentric model wants to say, but our model is so much cleaner and neater, and it's not nearly as complicated. And it does almost as good a job, if not a better job, of making the predictions that the Ptolemaic geocentric model does, but it's not crazy complicated. So our theory is better. Well, depends on which criteria you're using to evaluate theory. If theory A is using theory A's criteria, then it might well be that theory A looks preferable to theory B. And if theory B is using theory B's criteria, which is different than theory A, then theory B looks preferable to theory A. So, moreover, to some extent, proponents of different paradigms have difficulty even communicating with each other because they will use the same terms in the sense of phonemes, but they mean different things by it. So it's been charged, and I think there's reason for thinking this might be the case, that Newton simply meant something different by gravity than what Einstein meant. All right, so they're using the same phrase or phoneme, gravity, but it seems to be referring to a different set of phenomena and a different reality. within the theory, right? Within Newtonian physics versus quantum physics. So here's our cycle of the stages of science. We begin in pre-science, and then we move into normal science. Then there is model drift, model crisis, model revolution, and ultimately a paradigm change or a paradigm shift. Hume's account for scientific progress has sort of Darwinian evolutionary overtones. So certain Darwinian evolutional scientists talk about punctuated equilibrium. It's a theory that in evolutionary biology, which proposes that most species will exhibit little net evolutionary change for most of their geological history, remaining in an extended state of stasis, just kind of remaining the same. When significant evolutionary change occurs, the theory proposes that it is generally restricted to a rare and geologically rapid events of branching speciation. So in other words, what the theory of punctuated equilibrium means within evolutionary science is that you don't have a gradual evolving of the species. You have long periods of stasis punctuated by rapid change. So that seems to be what Kuhn is saying goes on in science. Long periods of paradigmatic normal science where the paradigm is unchallenged and worked within, punctuated by rapid change, right? The paradigm shift. It is not possible to understand, Hume argues that rival paradigms are incommensurable, meaning they can't speak to one another, right? It is not possible to understand one paradigm through the conceptual framework and terminology of a rival paradigm. David Stove and other critics of Hume claim that this account of science suggests that theory choice is fundamentally irrational and relative. If rival theories cannot be directly compared in some objective, non-paradigmatic dependent way, then one cannot make a rational choice as to which one is better. So what Stove is pointing out is, if there are no objective criteria by which to adjudicate competing scientific paradigms, if we can't actually objectively compare them according to this sort of proposed set of objective criteria, neither which is independent of either paradigm, then we can't make a rational choice as to which is better. And our preference of one over the other is going to be relative to something else. Hume himself denied his view had this result and sought to clarify his views to avoid further misinterpretation. So Hume was saying, no, I'm not advocating scientific relativism and that a theory might be true for you, just not true for me or something like that. And yet, even though he said he wasn't advocating that view, a lot of what he wrote seems to be advocating precisely that view. Freeman Dyson, another philosopher of science, had once quoted Hume as saying, "I'm not a Kuhnian." But nevertheless, Kuhn stresses the incommensurability in a number of different but related areas. Here are some of them. He wants to say that there is no neutral language. This is the most basic sense in which Kuhn uses the notion of incommensurability. The idea is that different paradigms, even if they use the same vocabulary, will use it in different ways, so that the scientists committed to the differing paradigms will tend to talk through each other, but not to each other. So they're not actually expressing the same thing, even when they're using the same words. The meaning of the word seems to be bound to the scientific theory in which it occurs. In other words, the meaning of the term seems to be occur within the paradigm. But you can't get to a theory neutral or paradigm neutral assessment of the language. So there's no neutral language. The theoretical justification here seems to be that any aspect of a theory can affect the meaning of its terms. This is very similar to the thinking of Willard Van Orman Quine, the 20th century philosopher, who makes exactly this claim. There is no distinction between analytic and synthetic sentences, between sentences which merely give the meanings of terms and sentences which reflect states of facts about the world. So there is no way to give a neutral definitions of words shared by different theories. Definitions that both theories could accept. So again, if the terms are defined within the theory, you can't get to a neutral definition that both theories could accept. Therefore, it's extremely difficult, Hume doesn't actually say it's impossible, for proponents of one paradigm to even figure out what proponents of another paradigm are really trying to say. It would require sort of being bilingual. So maybe I could be bilingual and put on my theory A hat and speak theory A, and then take off my theory A hat and put on my theory B and speak theory B. What I can't do is speak theory A and theory B at the same time. Observation, oh, there's no neutral observations. Now, this is basically for similar reasons. Observation is likewise theory-laden. What we observe depends to some extent on our pre-existing theoretical commitments. Our theories provide the categories in terms of which we classify our observations, and thus to some extent affect how or what we see. So one thinks about Galileo looking through his telescope, seeing moons going around Jupiter. Well, it seems to me that someone who had a different paradigm might look through Galileo's telescope and see nothing more than spots and aberrations in the lenses. The positivist ideal theory, the positivist ideal of theory choice was situated in which two competing theories made conflicting observational predictions. Then a crucial experiment was performed and one theory won the day while the other theory was refuted. So this is how verificationists and falsificationists like Kuhn, not Kuhn, like Popper, and the logical positivists would see theory advancing, right? A crucial experiment that you're looking for a set of observations which would be consistent with one theory and disprove the other. However, on Kuhn's view, things are rarely this simple. Often different theories will handle different sets of observations, and even where in some sense they overlap, they may not agree in their interpretation of what is observed. Think of the duck-rabbit drawing, right? So I might look at exactly the same thing that you're looking at, and I see a duck and you see a rabbit, right? Why? Well, because we're interpreting the one and the same objective, in this case, distal stimulus, but how we see it, what we perceive it as, depends on certain things that we bring to the party, certain interpretive devices, etc. Well, Kuhn wants to say the same sort of thing can go on in science, and that you're looking at the world through a certain theoretical lens. And so what results as a perception will depend on the lens through which you're looking at it, the theoretical lens. Two people can have or can look at exactly the same drawing and still in some sense see entirely different things. Third, there's no neutral criteria for theory choice. In his book, The Structure of Scientific Revolution, especially in chapter 9, Kuhn appears to suggest that each paradigm carries with it a set of evaluative criteria on which it scores well, so that there is no neutral criteria that will decide which theory is best. So if the criteria for theory evaluation is developed within the paradigm, then you can't get outside the paradigm to come up with neutral criteria for theory evaluation. In learning a paradigm, the scientist acquires theory, methods, and standards of evaluation together, usually in an inextricable mixture. Each paradigm will be shown to satisfy more or less the criteria that it dictates for itself and to fall short of those dictated by its opponent. So again, as a point we've made earlier, the paradigm scores well on its own internal criteria. And if all criteria for theory evaluation is paradigm dependent, then there is no neutral criteria for theory choice. In later writing, notably an article he wrote called Values, Objectivity, and Theory Choice, Kuhn takes what he seems to be a more moderate view, though he claims that this was what he meant to say all along, holding that there are general criteria for theory choice on which nearly everyone can agree. things like simplicity, scope, coherence with existing theory. So he's saying, well, I'm not saying there are no neutral criteria. For instance, almost everyone, regardless of what paradigm they might hold, would hold that simplicity or explanatory scope or internal coherence are values to be sought. And these recommend a theory, right? So maybe these are neutral, supposedly neutral criteria for theory choice. However, he then goes on to argue that proponents of different theories may well interpret these criteria differently. So they maybe don't mean the same thing by simplicity, or they have something else in mind by explanatory scope or internal coherence. So it's not clear that these are the neutral things that, at least initially, he seemed to be suggesting they were. Further, and maybe I'll say this in a future slide. Oh, I guess I don't say it here. Let's go back. But not only might they interpret these supposedly neutral theory, good-making qualities of theories differently, and therefore it's not going to be universal. But they may weight them differently, right? So there doesn't seem to be an objective way to say, well, scope is always more important than coherence, or coherence is always more important than simplicity, or something like that. So there may be no neutral, not only may there not be any neutral criteria, but even if we did say that there's quasi-neutral criteria, they aren't interpreted in a universal way or weighted in a universal way. And then finally, and this is perhaps the most radical of Hume's claims, there seems to be no neutral world. There's a sense in which the scientists are living and investigating different worlds, worlds of their own experience, worlds of their own interpretation, worlds as rendered by their paradigm. Now, Kuhn does not deny that there is a real world which is not affected by changes in our theories or paradigms, but nevertheless, he insists, in a way similar to Immanuel Kant, that the world we experience and live in is reshaped and therefore changed when our theories change. So if the world of our experience is a world that is partially rendered by how we interpret, and if our interpretations are guided by whatever paradigms we're working under, then a shift in paradigm will be a shift in our worlds. And there is no neutral world, if you mean by that a neutral world of experience. For instance, he argues that until the medieval period, there were no pendulums. There were merely swinging objects. So were there objects that swung back and forth? Yes, but no one interpreted those things as pendulums. Pendulums didn't come about until we had a new way of interpreting and engaging the world, speaking about the world, right? So again, the language informed our experience of the world. The enormous impact of Kuhn's work is evident in the change it has affected in the vocabulary of the philosophy of science. So notice in philosophy of science now, it's impossible to do philosophy of science without referencing paradigm shifts, paradigms, normal science, and scientific revolutions. Even if you think Kuhn was wrong, you have to take seriously the notions that he's brought to our attention. The frequent use of the word paradigm shift has made scientists more aware of, and in many cases more receptive to paradigm changes. Thus, Kuhn's analysis of the evolution of scientific views has by itself influenced that very evolution. Kuhn's work has been extensively used in social sciences as well as the natural sciences. Kuhn's analysis has been influential in understanding the history of economic thought, for example, Keynesian revolution and in debates in political science, etc. We might think about the paradigm of social conflict theory versus the paradigm of functionalism when it comes to understanding social structures and the evolution of societies. Further, it suggests the fruitfulness of social science examination of the natural science, actually taking social sciences and looking at how they affect what really goes on in the natural sciences. Notice how much of the early philosophy of science took the form of a rational reconstruction and was to a point an a priori prescription rather than a close examination of what actual scientists do. So this was Kuhn's criticism, saying Popper wasn't so much describing how science is done, but trying to prescribe how it ought to be done, and perhaps it's an impossible prescription at that. Post-Mertonian strong program in the sociology of scientific knowledge is one such examination. Kuhn's work has also been used in the arts and in humanities. Kuhn tries to defend himself against the charge that his account of science in the structure of scientific revolution results in relativism in a later work, Objectivity, Value, and Theory Choice. In this essay, he reiterates 5 criteria, which we had previously mentioned a moment ago, that determine or may help determine more properly theory choice. Accuracy, consistent, broad scope, simplicity, fruitfulness, etc. Nevertheless, he goes on to show how, although these criteria allegedly determine theory choice, they are themselves imprecise, subject to different interpretations by different researchers. And further, in practice, they're used differently by individual scientists, some according more weight than others to one criteria or another. According to Hume, when scientists must, I said Hume, I mean Kuhn. According to Kuhn, when scientists must choose between competing theories, 2 scientists equally committed to the same list of criteria for choice may nevertheless reach different conclusions. So that strikes me as an admission that, that science is fundamentally relative in this regard. There don't seem to exist objective criteria by which to adjudicate competing scientific paradigms. Thus, despite Kuhn's best effort to prove the contrary, in the end, there remains an irreducibly arbitrariness and irrationality to theory preference. This being the case, one still cannot call these criteria objective. If individual researchers come to different conclusions, despite the fact that none of them has done anything epistemically improper due to valuing one criteria over another or adding additional criteria, then these conclusions are relative, no one of them being right or wrong, right? So we're left back with the idea that there don't seem to be any objective criteria by which to adjudicate competing ethical or scientific systems. Further still, as Kuhn notes, even this picture presumes the absence of selfish or other subjective motivations, motivations of which the scientists themselves may be unaware. Thus, this may be an idealization as opposed to the actual account of how science proceeds. So in suggesting that these 5 criteria might be somehow used objectively and develop theory preference, that may be to the same extent doing what Popper was doing, idealizing and prescribing as opposed to a close attention to what's actually going on in the history of science. Kuhn then goes on to say, I'm suggesting, of course, that the criteria of choice with which I began, function, the criteria with which I began function not as rules which determine choice, but as values which influence it. Because Kuhn uses the history of science in his account of science, his criteria or values for theory choice are often understood as descriptive of the rules, or more properly values, of the theory choice for the scientific community, rather than prescriptive normative rules in the usual sense of the word criteria, although there are many varied interpretations of Kuhn's account of science. So notice, if all he's doing is describing how scientists have used values, then he's not saying they're doing it the right way or even that they're doing it the wrong way. He's just describing. But that's not our normal notion of criteria. Our normal notion of criteria is prescriptive. This is how we ought to be doing things. But it's not clear that that is what Kuhn is doing in this regard. Kuhn's metaphysical views. The 4th claim listed above, that there is no neutral world, appears to involve a commitment to some sort of metaphysical anti-realism about the empirical world, combined with an acknowledgement that there is also a real world that is not changed by our changing theories of it. Hume's view is here very much like the Kantian distinction between the phenomenal world, the world as interpreted by mind, and the noumenal world, the world in and of itself, the thing in itself. But for Kuhn, since there can be different schemes of interpretations, there can be different phenomenal worlds. For Kant, there's only one human paradigm, and so only one empirical world. So there is a similarity between Kuhn and Kant here, but notice the dissimilarity. For Kuhn, we end up with it looks as if a irreducible relativism where truth is relative to a particular theory, a way of interpreting the world, and there are competing multiple theories or ways of interpreting the world. For Kant, truth is subjective and relative, but it's relative to a single universal way of interpreting the world. For Kuhn, for Kant, all cognizers interpret the world the same way. Kuhn shares with Kant the idea that there really is a real independently existing world, again, Kant's thing in itself, which is completely unknowable, and that the empirical world, which is knowable, is partially constructed by our categories and concepts. Some suggest that it is inconsistent to claim both, that there is a thing in itself and that we cannot know anything about it. This was Hegel's criticism of Kant, for instance. Just as the philosophers who followed Kant tended either to be realists who argued that we can know the real nature of things, or idealists, like Hegel, who rejected the idea that there is a thing in itself, so post-Kuhnian philosophers of science tend to be either straightforward realists who think that science is giving us actual knowledge of the way the world really is, or anti-realists, such as social constructivists, who seem to reject the cogency of a mind-independent world at all. Personal footnote. I came across this on the web and I thought it was interesting. Sometime in this was a quote from some individual's blog post. And in his blog post, he wrote the following. Sometime in the mid-1970s, I was browsing the philosophy of science section of Dillon's, the London University bookstore. I pulled out Kuhn's book, The Structure of Scientific Revolution, for a look. A professorial type appeared alongside me and glanced at what I was reading and said, "Scientific revolution's my ass," and walked off. It was Karl Popper. I just thought that was a funny story. Okay. All right. Hopefully you found this helpful and useful. Naturally, if you have any questions, please let me know. And other than that, have a pleasant rest of your day.